Good morning all, and thank you for coming along. Welcome to the FME World Fair. If this is the first World Fair event that you've attended this year, thanks for coming along. But if you've been joining in since Tuesday, you might have been building up your reputation points on the platform or vying for prizes. Well done, and hopefully our session will help you along with your learning journey today. So our session is called User Stories and Effective Plate Spinning because the focus of this event is to showcase a little of our recent experience. And we're also really proud to presenting some stories from the wider user base out there to help you with a little of the context of just some of the elaborate challenges that you can pit FME against. Like I said at the start, thank you very much for registering and joining us live. It really means a lot to the team that you joined us today. And so I'd like to introduce you to the 1Spatial Pavilion team, who are here to help you across the two sessions, today and next Wednesday on the 12th of May. We've got Hayley, who's been responsible for putting the event together, and she'll be helping support the technology, allowing us to successfully broadcast the session. There's myself, I'll be your host, and I'm the FME Division Manager. You can throw techie or sales questions directly at me. But also, please post any questions that you might have for our guest speakers to me so that I can ask them on your behalf at the end of each session. Charlie's our client advisor. She's on the Q&A and will be responding to any of your commercial or license-based inquiries. We've got Mary and Simon. They're our principal consultants. You're going to hear from Simon today and next week, and Mary will join us on the 12th for a technical deep dive into a topic close to my heart. There's going to be a bunch of FME certified professionals from our FME division as well around today, fielding any technical questions you might have, and those will be answered live. You should see Ian Fletcher and Mark McLean, as well as Simon and myself in the chat window. So hopefully between the 5 FME techies that we've got supporting both events, we should have most of what you can cook up for us covered, hopefully. Especially since that with a quick check, I realised that we've got a combined FME experience of 60 years, which is a little bit of a number that sort of made me feel quite old. Any 1Spatial staffers should be easily identified, as after our names in Zoom, you'll see we've added 1Spatial in brackets, so you can easily spot us. Now you no doubt have some questions during the session. The beauty of attending an event like this is that you can post questions throughout the session. In the Zoom interface that we've just had a little practice with, you should see that you've got a chat option. You'll be able to send us a message either individually, or you can chat out a question to everyone so that everybody can see it. You can also leave us a message in our pavilion that you can access by logging into the FME World Fair platform. Jump to our pavilion and use the chat function there too. Feel free to send commercial or technical questions to us. We'll do our best to answer them today between the sessions, but if we miss you for any reason, we're going to gather a transcript of the chat and Q&A at the end of the event and make sure that everyone who's posted a question gets a response. So if we don't get back to you directly today, we will do in the next few days. Also, during the customer sessions that we've got shortly after the first session with Simon and myself, we're happy to receive questions that you might want to direct directly at the speakers. I'm going to be asking those at the end of their sessions, so do send questions, but please prefix the question with the speaker's name to avoid any confusion. As for sound and video during the session, Hayley is going to mute everybody. We've actually already just done that. I guess the main thing to say is don't be offended. It's not a problem at your end. We just want to cut down on feedback and echoes and dog barking and over-enthusiastic children, that kind of thing. So us muting you though, it's not going to stop you unmuting yourself again. So if anyone actually wants to come on mic at the end of a session to ask a question, by all means do. There's going to be an obvious slide appear to give you that cue. We just ask that you wait to ask questions till the end of each slot. If you want to turn your camera on to ask a question, you're also welcome to do that. We'll also try and unmute scheduled speakers at the right time. We're going to be cutting between live broadcast and pre-recorded sessions, just to keep things sort of technically exciting. We've pre-recorded the main sessions to try and limit the chance of technical problems that might happen, but we're going to be shuffling between live and pre-record, so those are going to be perfect slots for you to fire any questions you might have at us. So who are 1Spatial? If you just landed in our FME World Fair Pavilion and stuck around for the ride but haven't come across us before, well, really all you need to know in the context of today is that we're data specialists who care about data quality, and for 50 years we've worked with lots of customers around the world and their data and our technology. We also partner with some of the best third-party vendors in the market to ensure that our customers' solutions include the best of breed kit. And the vendor we're going to be focusing on today is Safe Software, who I know many of you are very familiar with. They make FME. We're a platinum partner and we've been working with them for 22 years. You can find our credentials on Safe's partner portal. But really, those of you joining today live no doubt managed to find your way to us via the FME World Fair platform. You probably stopped by the 1Spatial Pavilion. We've got 6 slots at this global event together, and all running in the English language, but sessions offered in 2 separate time zones. So that's Greenwich Mean Time for people in the UK and Europe, and also Australian Eastern Standard Time for our Antipodean cousins. Today our UK session focuses on trends and the experiences of some of our customers. Next Wednesday we're going to dive under the technical covers of FME 2021 and showcase some new features, as well as what is effectively a dedicated training course around regular expressions and webhooks. So they're the 2 technical topics we're going to dig into. Anyway, the agenda for today. First up, you're going to hear from myself and Simon, and we're going to walk through some common trends that we've been tripping over in the past year with respect to how we're seeing FME used and deployed. Then, because we're focusing today around some user stories, we're handing on to our 3 guests. We've got Gwilym O'Donovan. He'll be first up, and he's going to be looking at how FME helped him integrate their systems and workflows with a client's document management system. So that's a system called Asite. Next up will be Jenny Wilburn. She will show us how she worked on a project to identify where and by how much vegetation adjacent to our railway lines was encroaching on the routes, and how a small team could do a huge amount of data processing. And finally, Samuel Anstis will show us how his data wrangling with FME allowed him to enrich raw borehole record data to make it analysis-ready information, not just data. So sit back, strap in for the first part of this roller coaster ride. Let me launch the first pre-recorded session, and this is where I sort of unnervingly hand over from live me in the present to pre-recorded me in the past. But I guess, let's face it, it's far from the weirdest thing that's happened in the last 12 months. So over to you, Dave.
Welcome to our session focusing on the trends that we're seeing in the market in the way that both end users are using FME, but also how FME is adapting to make it more commercially and technically flexible for you to use just what you need when you need it. In this session, we're starting with a double act with myself and my colleague Simon Green. We're going to climb into a pair of hand-painted vintage bumper cars, or Dodgems if you prefer, and we'll attempt to bounce off each other for the next few minutes and hopefully deliver to you something slightly less painful than whiplash. Doesn't sound promising, I admit, but at least with an intro like that, it can only get better. Heraclitus, the Greek philosopher, said, "Change is the only constant in life." He was a pioneer of wisdom who lived over 500 years before Jesus Christ. His thoughts fed into the writings of Aristotle and Plato. Now, isn't that a grand start to a presentation? But why do I bring up such a highbrow quotation? Well, because the IT industry, and specifically the ways in which we store, serve and analyse our data, is changing daily. And I so often seem to find myself having to run just to keep up. There's a reason I've had FME as my jogging partner for the last 20 years. It helps me to stay ahead of the pack. So in this first session today, we wanted to share with you a little of our recent experience. Many of you will know that as part of what we do as partners of Safe Software It's to develop our skill and ensure we are always up to date with both the direction that FME is being developed in, but also the environments it's being deployed into and having to interact with. As a result, we see trends in the market and they come in waves. And the great thing about having access to FME is that you're able to react to those waves. Just to give you an example of what I mean, a little less than 10 years ago, we saw open source technology like QGIS, previously Quantum GIS, and PostGIS or PostGIS becoming a little more mainstream. Sure, those tools existed well before 2013, but as larger organisations started to react to challenges like the spending review of 2010, not having to pay for software gave companies a practical and enthusiastically supported alternative to proprietary tools. Of course, FME was here to help migrate data into formats and structures that these tools required, and we saw a groundswell of people buying FME to handle the migration from proprietary to open source standards. Some organisations we dealt with found their only nod to proprietary software at all was FME, because they decided that it gave them so much value it wasn't worth the risk of writing the ETL scripts or extract, transform and load in code, given the speed at which the technical landscape changes. Many of you will know that Esri is also a dominant player in our sector, and as a result it's generally a theme, rather than a wave so much, that we help customers move data to and manipulate it within Esri tooling, especially as the integration between FME and Esri is perhaps the tightest that exists. In the world of business intelligence, things are moving quickly too. Who even used the term business intelligence or dashboards in common parlance before 5 years ago? Now we have departments carrying the name and individuals with BI in their job title. And perhaps it's just another name for something we've always done, but certainly it spawned a new breed of dashboarding tools to be born. With early to market players like Tableau starting to now see their market share encroached on by Microsoft, who of course offer Power BI within their Office 365 suite. So perhaps, why wouldn't you use it? And if you don't have your data in a repository that can be easily consumed by your BI tool, or you need a way to keep it synced or refreshed, FME is here to help you schedule that task. So we have 4 key topics we want to share with you today to highlight a little of the flexibility we can offer commercially around the FME platform, but also what approaches some of our customers are taking technically as regards to how they're deploying FME and how they're consuming their data processing capacity more economically and more efficiently. To start with then, I'm going to share with you typical ways in which we see customers adopting an enterprise data processing capability, as well as how an FME subscription might be a useful way to procure FME to reduce the barrier to changing your license mix. Then Simon's going to touch on where our customers are deploying FME and how a new kind of engine available in FME Server is making infrequent but heavy processing demand much simpler to handle. To kick off then, I wanted to tackle the age-old question: how much FME is enough FME? Now, many of you that have joined us today will generally agree that you can never have too much FME. But seriously, how do you size your data processing capacity when you're starting out? Hopefully the next few minutes will help and demonstrate what we usually advise, as well as show you what sort of trends we've seen in recent years. Firstly, with FME Desktop, how should you use it to get the best bang for your buck? You'll probably already know that with FME Desktop you can use it with a fixed license that's available to one user on one machine 24/7. Or you can connect to a remote floating license server and share a pool of FME Desktop licenses with a collection of occasional users. There are also subtleties in the detail too, because floating licenses can be temporarily borrowed, turning them into temporary fixed licenses. And floating licenses can also be allocated to dedicated machines or users, allowing the budget holders who paid for a license to get full access to it. But irrespective of how many licenses you have, what's the most efficient way of using them? Our advice is simple: author by day, run at night. In a scenario where you've bought a single floating license that you're sharing between 3 people, you don't want a long-run job processing and loading data into SQL Server during working hours when the 3 users want to actually use that license to collaborate on a workspace to translate data between their CAD data and their asset management system. It's much more sensible to spend the working hours constructing the data integration logic into your FME workspaces, the scripts that do the work, and then call those workspaces at night in series through the use of a batch file. This simple mantra means that you can get value out of your investment in FME by day, but also at night and at the weekend. Better still, your data's where it needs to be when you need it, because it's been loaded, translated or manipulated when you were doing something far more interesting on a sunny May bank holiday weekend. In recent years, we've seen the business cases for FME Server broaden and deepen, with one recent client using FME Server to schedule staff payroll transactions, another using it to onboard staff to the organisation and revoke access to software to contractors at the end of their term. Another customer moving goods purchasing records between systems, and another conflating persons at risk data with partner organisations. Oh, and a few convert shapefiles too. If there's information to be extracted, and the information is buried inside data in an eclectic array of places, FME Server can usually be used to integrate the systems, often by triggering it to run via the API or scheduling it to run, or by getting it to watch or listen, if you prefer, for change happening somewhere on your network or on the internet. FME Server can then react to do your bidding, all from a robust and resilient deployment on your network or in the cloud. But not everyone starts with FME Desktop and FME Server at the same time. It's much more typical for organisations to buy one or maybe two FME Desktop licenses to prove their worth and identify other use cases once FME has paid its way with the original requirement. We then often see FME broaden out to a wider net of users by upgrading fixed licenses to floating instead. Then once multiple business cases have been identified, often across several departments, having FME as a service is much more practical and importantly much more robust. This is also the point at which often the initial flurry of workspace authoring to build processes to move data has calmed down a little, and FME Server can be used to host production processes that can run constantly, keeping your systems and your users connected with up-to-date information. The impact of this change in focus means that all of a sudden you could really do with a little more engine capacity on FME Server. So you add an extra, but perhaps fewer desktop licenses are required now because you don't need to do quite so much process authoring. And this is where it gets interesting, because we can help you to consolidate your license mix and shift your inventory so that it matches your new needs. Upgrading FME Desktop licenses to contribute towards additional server engines. The really cool thing about the pricing models is that in most scenarios, if the FME Desktop or FME Server license you once needed is now not fit for your needs, you can trade it in for credit against the capability you need today, reusing your historic investment against perhaps more FME Server processing capacity. So if you'd like our help to assess the utilization of your current FME license estate, just to validate where you are today and your needs, just drop us a line and we'll see if we can help you. And just before I hand over to Simon for some fairground puns, I just want to say a word about perpetual and subscription licensing. And really this part of the presentation is intended for those of you that are involved with procuring FME, but there's some interesting tidbits for the more technical of you too. I just wanted to touch on this topic because it's frequently a significant part of our discussions with people working out what's the best way to get FME into their organisation. Now you'll likely be aware that the traditional way to buy FME is under a perpetual license. What this means in practice is that you make the bulk of your investment up front, and then in subsequent years you just pay the component that covers your technical support agreement with us and the maintenance per license. This means that there's a capital expense up front and an operating expense after the first year. It also means you effectively own the license. However, in recent years we've also been able to supply FME to you via a subscription. For want of a better description, this is basically a rental agreement, in that whilst the subscription is active you have FME, but as soon as it expires you don't have FME anymore. A horrible thought, I know. With respect to subscriptions, there are local government, utilities, education and airport subscriptions, but since the majority of the thresholds are based on North American populations at the moment, in the most part these subscriptions are not quite workable in Europe. But don't let that put you off, because we can always work something out if you have a specific need. We've also noticed a trend though in the last 6 months around a desire to adopt a subscription, and This has been for customers who expect to grow their FME usage, or for whom the rental model better fits the way they license their broader software estate. In this case, an enterprise subscription is often a great fit, as it works by you paying one flat fee each year, and that fee entitles you to a certain value of FME software, roughly 3 times the value that you paid for your subscription. And for those of you actually using FME, knowing whether your organisation buys perpetual licenses or subscription-based licenses is useful, because it'll tell you how flexible and indeed how quickly you'll be able to change or scale your license mix on a project. If you buy perpetual licenses and you need some more, you'll need to make a request for a license, and that request will likely have to pass through the commercial procurement process, which might, depending on your organisation, take a little while. If you have a subscription and you haven't already used up to your threshold, you can just tell us what you want, and we then unlock an extra license or 2 for you for FME desktop or server. You can also reduce your license count, add a development FME server environment, or move capacity from fixed desktop licenses to floating. So on the face of it, how you buy FME might sound like a dull topic, and to be fair, it's hard to make it super exciting, but it's key to how quickly your project might be able to react to a change in direction, so it's worth looking into if you haven't already. Anyway, that's me. So time to swing my trapeze in Simon's general direction and hope that he catches me. Simon, all yours.
Thanks, Dave. Across the industry, we are seeing a continued growth in customer cloud deployments of FME, and that goes for government too, especially with the need driven by central government to, where possible, adopt a cloud-first strategy. We're seeing more customers wanting to deploy FME desktop into environments like Citrix that support thin clients, and with the current need for home working, it's much more common for entire companies to run almost an entire infrastructure in the cloud based on Azure virtual machines or AWS EC2 instances. In a few cases in this last year, for customers who couldn't put their company credit card into one of these environments because they have to use the more traditional PO and invoice approach, we've even supplied the hosted platform and installed FME so that the whole environment is ready to go for the end user. Historically then, we saw a lot of bias, at least in the UK market, towards Amazon Web Services or AWS, but part of that demand was driven by the fact that for a good while, technically Jeff Bezos's cloud product was a good 18 months ahead of the closest rival. But these days it's hard to argue with Microsoft's marketing department, especially when it's not uncommon to see an advert for Azure on the TV in the ad break between an episode of Coronation Street. And the impact of that marketing engine has directly affected the 1Spatial FME division's day-to-day work by shifting the cloud bias towards Azure over the last year or so. In the last 6 months alone, all barring 2 FME server deployments that I've completed have been on Azure, with one of the 2 being on-premise and the other being on AWS. Now, some of you be well aware that FME Cloud is a managed and hosted solution that we offer, and you'll know that it's effectively FME server in the cloud, but you might not know that it's hosted on a Linux machine in AWS. SAFE's next move then, having recognised the shift needed to balance the offering a little, and to that end last year released a number of cloud marketplace offerings. As a result, you can now go to either the Google Marketplace or the Azure Marketplace, and in a few clicks configure and buy access to a virtual machine with both FME Desktop and FME Server already installed and configured on. All you need to do then is buy a license from us, and we'll help you add the serial number to the software. No longer do you need to find a server in your environment or schedule someone to help you install on that server. The license model is called Bring Your Own License. Focusing a little more on FME Server then, as I will for the rest of this session, an interesting option became available in December. An Azure Marketplace offering of a Byol distributed deployment of FME Server, this is effectively a pre-configured way of deploying a more resilient and scalable infrastructure platform for FME Server, featuring options to make the FME environment scalable when your demands change. In practice, we found this configuration great if you're comfortable with all of the configuration decisions that SAFE have made on your behalf, things like operating system choice and security settings. It's also a great way of testing a distributed deployment without having to go to the trouble of deploying your own manually, just to find out it's not quite what you were looking for. In our recent experience at least, we found that there's generally a need for something a little more bespoke. At 1Spatial, we've deployed a lot of custom FME server installations into Azure and other environments on behalf of our customers. Our FME consultants have relevant cloud certifications to keep us relevant in this new environment and allow us to give the best advice. FME server deployment options can range from the very simple, a single VM, no resiliency, to complex, multiple VMs for resiliency, and something in between. Hold tight as we take a ride through some of these deployments. In this first example, we can see that it's a very simple deployment where all the FME server components are located on the same machine. We've got the FME server web application here, the FME server core and job queue, the FME server system database, the FME server system share, and also the FME server engines. This kind of deployment is typical of an FME Server Express installation, which incidentally is now also an option for FME Desktop 2021. An Express installation that is, making it simpler than before to get up and running with FME Desktop and consistent with the approach with FME Server. So in this example then, as everything is installed on a single VM, there is no resiliency in FME Server with this deployment option. So the assumption here is that frequent imaging of the machine, e.g. EC2 instance or Azure VM, etc., occurs. This offers some peace of mind if the worst was to happen, but some content could be lost between machine image intervals. In this example, engine capacity can be scaled as long as the machine has the resource capacity or it can be resized. So like the first example we saw on the previous slide, this again is a single machine deployment of FME Server. It's a simple deployment option, but this time it offers some limited resiliency. We can see that the database and file share have been separated out from the main FME Server installation. In Azure, it's recommended to use an Azure Premium file share. Assuming that these two resources are configured for failover, then this is where the limited resiliency in this deployment lies. The database and file share are fundamental to the overall running configuration of FME Server, so having some form of resiliency here is important. This kind of deployment also allows for added operational flexibility. One such benefit means that if you want to add extra machines into the configuration, such as a distributed engine machine, then this deployment allows for this type of scaling. Again, like the previous example, the assumption is that frequent imaging of the machine, e.g. EC2 instance or the Azure VM, etc., occurs. If distributed engines are not going to be added into the mix, then the engine capacity can be scaled as long as the machine has the resource capacity or can be resized. Our last example here is a fully resilient deployment, offering resiliency at all tiers. You can see we have a load balancer or web application gateway with two FME server cores sat below. Each core has a separated distributed engine machine here and here allocated to each core. And again, we have a separate database and file share. It's important that each core and engine machine in this deployment have a direct connection with both the database and file share. So how does this resiliency work? Well, if an FME server core was to go down, assuming that the load balancer is configured correctly with the FME server health check, requests will only get sent to the machine that is live. Any distributed engine machines associated to the downed core are automatically allocated to the remaining FME server core. It's important to recognize that these engines will remain allocated to that core host until such a time that the downed core is returned and the engines are manually reassigned to it. This kind of deployment allows for a good degree of flexibility. Both engine and core machines can be increased to maximize processing capacity and application resilience accordingly. What we've seen on the last few slides gives a flavor of some of the common deployments that our customers have. It is by no means exhaustive, as there are an assortment of other variations in place. The next topic I wanted to talk to you about is dynamic engines, but I don't want to get into it straight away because dynamic engines are exclusive to FME Server, and I just wanted to quickly explain what options you have for bulk processing if you haven't yet got access to FME Server in your organization. I'm confident that many of you have at some point needed to perform bulk data processing batch processing if you like. Common use cases are using FME to process hundreds of OS master map topography layer GZ files into your Oracle database in bulk, or downloading land registry open data zip files, extracting them and inserting the contents into a table in your PostGIS database. If you have to do these sorts of tasks one file at a time, you can find that you end up waiting rather a long time to complete the load. But if you have tripped over a special transformer called the workspace runner, you'll know that with a technique sometimes known as running a parent-child workspace, you can actually load up to 7 files concurrently with FME Desktop if you have the hardware that can cope with that kind of throughput. If you'd like to know more about the workspace runner, just dive over to the FME community and use the search term batch processing using the workspace runner to find an article to help you. With FME Server then, there hasn't really been a true answer to the workspace runner other than of course buying more engine capacity. That might seem a little unfair perhaps when you first start using FME Server, that you're limited to one job for every standard engine that you've got, but when things go wrong, it's the infrastructure around FME Server, like the queuing technology and scheduling tools that comes as standard, that makes it resilient and, in an enterprise environment, the right choice over FME Desktop for large processing jobs. Anyway, why am I telling you this? Well, because now there's a new kind of engine, and if you have a little dynamic engine credit and hardware that has plenty of power, you can now start as many engines as you need for the period that you need them, without the requirement to buy each one, or essentially scale your processing power for your processing peak rather than just when you need it. Strap in then for dynamic engines. To maximise the return on investment with traditional FME server licensing, you strive to keep standard FME engines as busy as possible. Having a dormant standard FME engine is effectively money that could be used better. However, this is not the case with FME dynamic engines. If it isn't working, you're not paying for it. This allows you to have dynamic engines started, listening for tasks and ready for work at no cost. You can rest easy and enjoy another go on the merry-go-round. Dynamic engines are designed to work alongside standard FME engines and are, in their nature, flexible. Launch as many or as few as you want, whenever you want, dependent, obviously, on available machine resource. You wouldn't want to start 100 engines on a 4 gig 2 CPU machine, for example. A workspace may run for several seconds, minutes, possibly hours, or even days, and it might be that large portions of that time is spent waiting for data, like asking a database to respond with a result, or likewise an API. If that's the case, then that time spent waiting doesn't burn through your dynamic engine credit. It's only when a dynamic engine is doing work that your credit is drawn down. By using the FME Server REST API metrics endpoint and automations, it's possible to assign dynamic engines to address peak workload workflows. It's common for customers to initially purchase FME Server with 1 or maybe 2 standard engines, allowing one workspace to be processed at a time, or a couple concurrently, but no more. As usage increases and more demands are placed on FME Server, this capacity isn't always enough, or there are points in your schedule when you really need more capacity, especially with demand spikes from popular FME Server apps, or when important daily processing tasks clash with large quarterly data loads. Additional standard engines can be purchased, but they can sometimes be hard to justify at the early but fast growth stage of your usage. And it's even harder to justify if they are only utilised, say, every few weeks when you have a peak load. Perhaps this is where the concept of dynamic engines could help, especially as they are designed to deal with bursty or spiky demand. With demand spikes in mind, let's explore the concept of handling these with dynamic engines, and how better than with a demo. Right, let's see how dynamic engines can help us. Day to day, I have a single standard engine running on my FME Server environment. It's working pretty hard and I'm struggling to find processing gaps. A colleague comes to me asking whether we could host an FME Server workspace app for an internal consultation that will run for a couple of days. This is going to place an unknown, potentially spiky workload on an already stretched capacity. However, as luck would have it, I've just activated 100 hours of free dynamic engine credit. What are the chances? I can now start up a number of dynamic engines ready for the consultation period, I'm now going to start up 5 dynamic engines. You can see these engines appearing in my engine list shortly. So there we go, there are the 5 engines. Now we have the dynamic engines, let's take a look at the FME Server Workspace app. It's a brief consultation to capture people's feelings about potentially returning to the office. This app uses a consultation workspace located in the FME Server repository called FME World Fair. So returning to the engine management page, by creating a job routing rule and assigning a queue to the FME World Fair repository where my consultation workspace is stored, and then configuring an engine assignment rule, any job in that queue will be routed only to dynamic engines. This means that my standard engine will not be impacted by this unpredictable workload. You can see the queue server app assigned to each dynamic engine. In the background, I'm going to simulate a number of users using the consultation workspace app by programmatically submitting their responses. So with those responses submitted, we can jump to the completed jobs page and see the engines being used to run each workspace. So we can see the dynamic engines have been used exclusively to run the consultation workspace that is used by the FME Server app, meaning that the standard engine has not been used at all and is free to do the work that it needs to do. So a couple of days later, the consultation period is closed, the FME Workspace app is disabled, and the dynamic engines can either be left dormant, reduced in number, or removed. But what about my dynamic engine credit, I hear you cry? It just stops being used. Until the next time you need it, it doesn't expire either. Now, if anyone listening thinks that's an interesting concept and you'd like to try it for yourself, just drop us an email at fme@1spatial.com and we can give you 100 hours of free dynamic engine credit of your own to try the approach. As far as what prerequisites are required, you'll need to have an FME Server 2020 or greater installed, and it will need to be on an internet-enabled server to set up the capability. So, there you go, 4 quick topics around recent trends that we wanted to share with you. Just in summary then, if you've been using FME for a little while, and you could do with help assessing whether you have the right license mix today, just give us a call or drop us an email to fme@1spatial.com. We'd be happy to assess your usage and offer some free advice. With regards to subscriptions, if you're starting your journey with FME or it's already got an established user base but you need to add to it, ask us about the options with a subscription whilst you're at it. With respect to the trends we're seeing with cloud deployments that I covered earlier, we know that not every organisation will or can move to the cloud. We also know that trends quickly change, but what I do want to say is that whether your organisation is likely to deploy any software, let alone FME in the cloud, I suggest you personally consider what you might need to find out about cloud deployments, if only to secure your relevance in the current IT climate. Because deploying software in a mixed infrastructure estate is here to stay, and for your own personal development, it's worth being aware of the rapidly evolving cloud topic to help you should you move your employer in the future. And lastly, the addition of dynamic engines to FME Server is, in my humble opinion, one of the most exciting features to be added to FME Server for a few years. The ability to scale your capacity at the click of a button is amazing. And for those of you wondering why the engine type is called dynamic, but at the moment you have to physically provision more capacity yourself, well, you won't have to wait long before FME Server becomes truly sentient and starts monitoring your job queue for a backlog that justifies it starting up more capacity for you. Anyway, for now, that's Dave and I done, and I'm going to hand back to our future selves in the live broadcast for any questions and to hear from some of our customer case studies. Thank you.
Thank you for that. So I think we've got a few questions. I've had a few as direct messages, and there's a couple that have gone out to everybody. So I'm just going to spin through a few that I've seen just to begin with. So there was one message that said we've got 3 fixed licenses, but we're considering changing to floating. How many floating seats should we get? So in a scenario like that, it sort of depends on. I guess the question is to have a think about is how much do the individuals that are using FME Desktop need to use it? Do they need permanent access, or do they need occasional use? In that scenario, generally, if you've got 3 fixed licenses and you go into floating, we tend to be conservative with our recommendations. So you might want to consider 1 or 2 floating licenses, because you can then install FME in lots of places. It also means that you can put with a floating license, you can put FME on a multi-tenanted remote server that people can dial into concurrently, so that becomes helpful. Simon, there was one that came in about dynamic engines from Steph. I don't know whether you want to pick that one up.
Yeah. So the question was, are dynamic engines only for FME Cloud, or can we use in just FME Server 2? So they are specific to FME Server. There isn't a concept as such as dynamic engines in FME Cloud. The licensing model with FME Cloud means that you can actually spin up as many engines as you require in that environment. So ever so slightly different. But dynamic engines are FME Server only.
Yeah, I guess on cloud, really, when you've got a cloud machine, you're sizing your capacity based on the machine size. So it's the hardware that you're renting that determines how many engines you can get away with deploying. So I think the smaller cloud instances, those are 2 CPU. If you're doing lots of HTTP request kind of workspaces, you could probably get away with running 3 or in some cases even 4 engines on one of the smaller cloud instances. Although you'd need to do a bit of benchmarking around that. But fab. I got asked if dynamic engine credit expires after a year, and the answer is, at the moment, no. It'll roll through, so if you don't use it, you don't lose it after a year. So you can top it in. You can add it to your serial number and then use it when you need it. I had one about server spec, Simon. So it was basically what sort of server spec do you need for FME Server? I mean, that's a bit of a big question, but can you?
Yeah,
can you do that justice?
Yeah, it kind of depends on the type of deployment that you're going for. So if you're going for a distributed installation, like we saw in the last sort of deployment diagrams that I showed in that presentation, where you've got a separate FME server core and a separate FME server engine, then you can spec those machines slightly differently. So the FME server core typically doesn't need quite as much oomph as an engine. So for a server core, maybe 4 cores, 8 gig and 50 gig of hard disk space, something like that. And then if you're speccing an engine machine, again, it varies on what type of work that engine machine is going to be doing in processing. So typically we'd say 1 core per FME engine. So if you've got 4 engines, then you'd probably want to have 4 cores, and then maybe a couple of extra cores if you've got any co-located tools on that engine machine like ArcGIS Pro or Desktop. And again, we'd probably recommend between 16 to 32 gig of RAM, depending on the type of the tasks that are being completed. So if you're doing a lot of point cloud or raster processing, then the more memory you've got, the better. And then again, from a hard disk point of view, you probably want 50 gig for the installation side of things, and then quite important to have like a separate drive or separate space available on that engine machine for the FME temp directory where it can write temp files. And again, typically we'd ideally recommend an SSD. Now, if you were having everything installed in a single VM, like the Express installation, then we'd probably suggest using the specs from the FME server engine that I just gave there to give you a bit of a ballpark for the specification. I guess the beauty if you're deploying into the cloud is that if you don't quite get it right with the sizing of your machine, so you overspec it or underspec it, then you can resize it pretty quickly and relatively straightforward without messing up your installation of FME server.
Yeah. Okay. Thanks, Simon. Just noticed a message coming in from Martin there. Quite a nice question actually. Is there a way of understanding effectively whether a larger server instance is actually being spiky in its processing? This would help to understand whether a dynamic engine approach is more suitable. I mean, I'll try that to begin with. I mean, our general approach would be, in this case, the FME server database is your friend. Because that stores your processing history. So for a couple of customers recently, we've helped them do an audit of their usage. And the principal thing here is that if you want to be able to understand over a period of time what kind of activity you're having, you need to go in and make the sort of database cleanup rules a little less aggressive. So that you sort of prolong the amount of data that gets stored about your historic job runs in the database. And we tend to say, try and keep 3 months of history, because then if you, I mean, we've built some workspaces that you can rattle across your database to go and filter out some metrics to see what sort of load you've got at what times of day, if there's particular days or time slots that are heavy usage. So that would be the approach that we would take is interrogate that database. I don't know whether you've got anything to add on that one, Simon.
Yeah, I mean, if you didn't want to start scraping the FME server database for stuff, then you've got the potential of the built-in dashboards to give you a sort of a brief summary. I mean, it depends what kind of level of detail that you want to go into, but the dashboards is probably a good starting point. Doesn't take too much to set up, and then as you said, Dave, review your cleanup tasks to make them retain those log files and job histories for a little bit longer, and then start running workspaces over that database to bring out queue times and job length running times and to identify some potential gaps in that capacity and see whether, as Martin asked, whether it is spiky.
Yeah. Okay. Andrew's posted a message about subscriptions and how that impacts UK customers in local government. It's basically a topic I think we'll need to pick up with you independently, Andrew, to look at what kind of needs you have. Certainly there are subscription options for local government and for customers in general. It sort of depends on what volume of licensing you need. That will work out whether it's worth you considering a subscription. In some cases it doesn't make financial sense to move from Perpetual if your need is small, if you've got a need for just a handful of licenses. But if you can see that you've got a growth trajectory where over the next couple of years you're going to need to add in a few more floating licenses and then maybe add server in 6 months' time, well that's where a subscription conversation is worth discussing. So we'll reach out to you separately about that one. There was one last one, I think, just before we draw a close to this. Simon showed an app in the second part of the session for returning to the office. Can apps be made external to an organisation, or can you only use them inside your own network? Do you want to go for that one?
Yeah, that's a good question. So if you've got FME server installed in your private network, then yes, apps can be made available externally, but you might need to befriend your security and networks team to make that publicly accessible. And I guess there's going to be some questions asked about that. I'm sure. But yeah, no, it absolutely is possible. It's not the easiest thing necessarily in the world to do. So maybe the simplest way actually is to have FME server installed in a public place like the internet. So maybe an FME cloud instance, that's going to be your easiest way to have a publicly facing application, and it's obviously in safe zone AWS environment, so it's nice and safe and secure as well, so you don't have to worry about security loopholes and things like that, because that's all managed on your behalf. So I guess, you know, depending on where your FME server is located really determines sort of how much effort is required. So if FME server is on a public network, then it's pretty straightforward. And as I say, FME cloud instance is going to be your easiest route to a public app.
No, we've got a customer that's done exactly that actually. They use FME server internally. They had a requirement to have some public-facing apps, but only for a relatively short period of time. We spun up a cloud instance for them, loaded some credit onto it, and they ran it for that fixed period, and then they turned it off. They've got it there to use for other things with a little bit of credit left on it, but it served its purpose for that sort of that external requirement.
Yeah. So yeah, I mean, if it is internal in a private network, then yeah, networking security teams will need to do a bit of configuration. So yeah.
All right, super. Well, I think we're going to switch over now. Thank you all for throwing your questions in. Appreciate it. We're going to take a look at the next speaker. So I trailed Gwilym at the start. So without further ado, we're going to go into our first speaker of the session. So over to Gwilym.
Hello everyone and welcome to this session. Today I'm going to be talking about how I have unlocked an API and I've got FME to streamline cloud collaboration. So a little bit of information about me. I'm a GIS consultant working for Mott MacDonald in Cardiff. We're a global engineering, management and development consultancy. And today I'm going to be presenting on how I've used FME to access an API to streamline project workflows which were previously completed manually. So what is an API? An API stands for Application Programming Interface. It allows two applications to talk to each other. And for this specific talk, I'm going to be talking about the A-Site. So A-Site is a document management system and it uses a REST-based API. So REST stands for Representational State Transfer. It's an approach for getting information content from a website by reading a designated web page which contains information. REST is a set of architectural constraints. It's not a protocol or a standard. You can access the URL via HTTP or HTTPS performing a selected function. So you can perform these functions, whether that be a get, a put, a post, a delete operation, which essentially means you can send the HTTP get function to call exposed methods and you'll get back a document or a file in return. So this is a quote I got online, which I think sums up an API very well. If you think of an API like a menu in a restaurant, the menu provides a list of dishes you can order along with a description of each dish. When you specify what menu items you want, the restaurant's kitchen does the work and provides you with some finished dishes. It's also a way for an organization to share resources and information while maintaining security, control and authentication, determining who gets access and to what data they get access to. So what was the project scope? This was an internal project where 2,500 documents were stored on a client's A-Site document management system. All of these documents needed to be reviewed by the project team. Previously, each file was manually downloaded through a browser interface, whether that be Google Chrome or Microsoft Edge. And as you can imagine, they were getting a lot of manual errors when downloading latest documents. So there were 5 main key tasks which had to be performed. The first was to replicate the files from a site to our internal SharePoint site, which was approximately 2,500 files. Number 2 was to synchronize these files periodically. That would be daily or weekly. Number 3 was to map metadata between a site and SharePoint. Number 4 was to update the document register for the project team. And number 5 was to notify the project team with an alert or a notification if there was a new version of the document downloaded during the synchronization. So the solution was, of course, FME. The problem was that there were a lot of digital documents stored externally which had to be reviewed, and the result, well, that was screenshot on the right was a screenshot of the email which was received by the project team on a daily basis. So this was the solution, design solution. This is a screenshot of the FME workbench that was generated. It used 52 transformers in total, with the main ones being the HTTP caller. The A-Site API uses the XML format, so there was also a lot of XML fragmenters, XML formatters to try and strip out the relevant information. So for the A-Site API, there were 6 main API calls which were needed. The first was to log into the API, which returns a token or a session ID. This was unique to the username and password sent in the post request. Number 2 was to retrieve the workspace list or the project list, which each user had, or which my user had access to. Number 3 was to get a folder list for each project or workspace. Number 4 was to get a list of all of the documents, which there was a max return of 250 documents. It's a bit like a website where you hit next page if all of the files aren't there. Number 5 was to call a next page document list for that exact reason, and the final HTTP caller was to download the documents, the relevant documents. So we also used a feature merger which only downloaded documents which were not already inside the document register. So this is an example of the emailer transformer inside FME, which was very handy. On the left, we've got a snippet of the HTML code that was used, and on the right is the output of that, which was sent daily. Now you can strip out the HTML code from any email inside Outlook, which is very handy, and then with some tweaks, we've added our own images to the email, as well as hyperlinks. It also tells them the automation process has completed or failed, date and time of when that was completed or failed, how many new documents there were, and a link to the document register. So some tips that I found. The first one was the token which was returned, or the session ID from the first login API call, has to be used in any further API calls using the cookie header in HTTP caller. I also converted the workbench to a Windows batch file for further automation, which could then run inside Windows Scheduler. So we have FME Desktop. Each day, or previously, I was logging into FME and clicking run. However, you can actually convert it to a Windows batch file, and each time you log in, it will start the process off, or you can set it at a set time, for example, at 7 AM each day, and it'll run the workbench for you as soon as you log in. So some of the results, we achieved efficient delivery of this project with FME. The weekly duration reduced from 4 hours of manual processing time to 4 minutes to run the workbench daily. The automation started on the 15th of February this year and is ongoing, and the project duration is anticipated to be greater than 156 weeks. So some of the other results, so we managed to download all the documents. That was completed. We updated the document register on a daily basis with document titles, hyperlinks to where that document was stored on SharePoint, as well as other associated metadata. This was also turned into a Power BI dashboard for the project team, so it could be used as one source of truth. And it had filters inside that, so they could easily locate the document they were looking for. Another result was the automated email. So with a bit of HTML coding inside the email transformer, we could add photo attachments, for example, the company logo, and it also included an automated daily download report, which is on the left-hand side at the bottom, which included things like file name, file type, the document revision numbers, the published date, and the download time and the status of that download. So in conclusion, FME was the perfect solution to performing this automation task. It is very interconnected with other programs very effectively, and it helped the project team manage hundreds of documents, all in an automated way. So thanks very much. And if anyone has any questions, please do shout out. Thanks a lot.
There we go. Thank you, Gwilym. So it's interesting, you know, the A-site connectivity and sort of document management systems. I'm sure some of you have started to look at this capability. It's obviously, it's not an immediate realization that FME can connect to these kind of tools, but certainly it's possible. You'll have found connectors perhaps for a few such tools. So there's connectivity to document management systems like ProjectWise, Autodesk A360, SharePoint. Of course, SharePoint's now fully integrated with FME through the SharePoint online connector and the SharePoint web connections that are available. So really interesting to hear connectivity to another system. Gwilym, I don't know whether you want to come onto a microphone and show yourself briefly. We've got a couple of questions. If anybody wants to put any other questions into the chat, I've got one for you just from my own observations. What were the actual documents that were being moved around? Does A-site support any file format? Was it sort of AutoCAD DWGs? Were you shifting PDFs or Excel spreadsheets? What kind of thing was it?
It was absolutely everything. So it's CAD DWGs, PDF documents, so PDF drawings, as well as reports, so Word documents. So yeah, anything the project team needed, we had to download and try and automate that. So
right.
Yeah.
Right. I had a message. I think it's about Power BI. Yeah. So you mentioned Power BI at the end. Did FME keep that dashboard up to date? And if so, what format was Power BI consuming its data from?
So that was actually a project manager's task, the Power BI dashboard. However, it was reading the document register that was automated by FME. So that was synchronized to SharePoint, and the Power BI was just reading that Excel file from SharePoint.
Okay. Okay.
Yeah.
Fab. Okay. Well, That was great. Thank you very much, Gwilym, and really appreciate you joining us for today's session. So thanks a lot.
No, cheers. Thanks a lot.
All right. Cheers. Thanks. Okay. So switching over to Jenny Wilburn. So let's just kick this session off, and then I'll see you again shortly.
Hello everyone, it's great to be here today to be able to talk about Network Rail's vegetation encroachment problem and how FME was able to solve this in large part for us. I know many of you, but for those of you that don't know me, I'm Jenny Wilburn. I'm one of the senior GIS consultants at Atkins, and I've been here a few times, so thank you very much for having me back again today. So what's the challenge? Well, Network Rail managed 20,000 miles of track. There's somewhere in the region of 10 million trees across all of that track. And they have to manage the trees and the other vegetation continuously. And it's a really significant task. They've got to keep the lines clear. They've got to compensate passengers when there's delays due to vegetation falling on the tracks. They've got to repair the damage to the infrastructure caused by the vegetation. And it all adds up. Simply getting people on track to cut back the vegetation is also a really huge task. Most importantly, vegetation inspections are currently done on foot. So to find out where vegetation is encroaching onto the rail lines, people have to be sent into a hazardous environment, even when the lines are closed, so there's no trains there. This makes managing vegetation somewhat dangerous, expensive, and something that data could probably help with. So data about vegetation exists in Network Rail already. They have LiDAR data for most of their track. Data about the track exists. They know exactly where the track is. We've got plenty of geospatial data sets on that. So a little bit of human expertise coupled with FME could make the vegetation data and the track data useful and help answer this question of where vegetation is encroaching. So today, we're going to have a look at that in a bit more detail. I'll have a quick project overview. We'll look at what Network Rail's written standard is for vegetation management and how that can be converted to something that FME understands. A few top FME tips, and how FME and an agile methodology for R&D actually really worked well together. And I hope that's something that's an element you can really take away from this and apply to your own projects. So on behalf of Network Rail, Atkins were commissioned to deliver a proof of concept to R&D, showing how existing data could be used to digitally inform track managers where vegetation is encroaching on the rail line. It's joint R&D, so Atkins were working on behalf of Network Rail, and you'll notice throughout this there's quite a lot of areas where I'm not able to give you large amounts of detail. Network Rail owned the IP for this. It was a really successful project, and it's an R&D project that went straight into production, which is quite unusual. Often things stall out of R&D and it takes a long time to get them into production, and we'll discuss why I think it was able to go to production so quickly. So what is Network Rail standard? Well, the standard for managing vegetation looks a little bit like this. You've got train in the middle, and you've got a red box around that, and that area is the immediate action area. We're saying there's no vegetation allowed in that area. And then we've got an action area around that. So it's underneath the lines, to the right-hand side of the lines, and above the lines, a kind of 45-degree angle out from the outer rail. And that's in orange on this diagram. And here we're saying it's possible that vegetation could be present, but we need to be very aware of it, and we need to have a management plan for it. So we treat it slightly differently to the immediate action area where we cannot have vegetation. The alert zone around the edge in green, again, nice to be aware of it, but it's not encroaching and it's not part of this project. We're not looking for vegetation in that area. Now, this picture here needs to be interpreted into zones that we can get FME to understand. We spent a long time working with the client to work out what zones met the specification, but also met our need for FME to understand it. We came up with this. The immediate action area is in the middle. The basic action area is in yellow, just to the outside of that, and the extended action area on the far left and far right in orange. The immediate action area is 1.25 meters away from the outer rail, or 3 meters from the outer rail if overhead line electrics are present. And if there are signals present, the immediate action area expanded to go around the signals and then contracted again. So it was kind of dynamic in its definition. Then the basic action area extended up to 6 meters away from that outer rail, and the extended action area extended up to 30 meters away from the outer rail. The extended action area has a 45-degree angle bottom to it. So you draw a line from the outer rail at 45 degrees out to 30 meters away. And only things above that line are encroaching. So for example, what we're really trying to do here is capture high trees. Because if a high tree fell over, it could impact the rails. Whereas lower vegetation, 25 meters out from the rail, for example, it's not a risk. We're interested in managing the vegetation we need to manage, not necessarily everything in the vicinity. So once we've got our standard, we wanted to make sure everyone understood exactly what this was, because as cartographers and GIS experts, we're really used to seeing diagrams like this, but a lot of people are not. So we created a kind of quick 3D visualization of what it looks like. So we had one on the left-hand side like that, showing the 3 different zones. We actually evaluated all the vegetation's height relative to the height of the rails. So you can see on the left-hand side, you've got a full terrain DTM, and on the right-hand side, we flattened it out because we're evaluating the height of vegetation to the nearest outer rail. This meant that the terrain wasn't overly influencing our results. In FME, we tended to work in 2D. And that meant that when we're doing a top-down view, so you can see the rails on the left in black lines, you can see we've got 3 zones with the rails in the middle, quite understandable. There's a little blip in the red on the far left where it has a little tongue sticking out. That's the signal, so it's gone around the signal. And on the right-hand side, you can see that we've got the same diagram, immediate action area, basic action area, and extended action area, but for quite a complex area of track. I think that's in Cardiff. So we could show that FME was able to generate these areas for simple line tracks on the left and more complicated tracks on the right. So what did we actually do to generate the results? We've got areas, but I haven't talked about where we were getting data from. Well, primarily, we were using LiDAR data to tell us where the vegetation was and how high it was, pre-classified LiDAR data. We also had ASCIIs, shapefiles, KMLs, TIFFs, LAS files for LiDAR, DGNs, geodatabases, API calls for getting signal information and connections to Azure, Excel, you name it. We had so many data formats. And I'm not able to go into a particular amount of detail here, but you can see the actual model workspace on the right-hand side. And there's all of those different FMWs that created the model. It took 18 months to build. It's probably the most substantial FME project I've ever worked on, and in fact I've ever seen. So we had to take a lot of data to create our results, and all the data, all those different formats, impacted our vegetation encroachment results in some sense. So primarily we used where the lines were to generate our zones, and then we used the LiDAR data to tell us where the vegetation was. We wouldn't have been able to do that without FME. Not quickly anyway. The sheer number of data types would have been prohibitive to doing it in most other software packages. And whilst it would have been possible, it would have taken a very long time. And then we got results that look a little bit like this. So this is a 2D looking down view. And you can see the dark red. That's vegetation that's encroaching on the tracks in the immediate action area. The orange is vegetation that is encroaching on the tracks in the basic action area, and the yellow is the extended action area encroachment. So notice in the yellow that there's quite a lot of vegetation around the yellow that is not coloured in. That's because it's below the 45-degree angle, and we're only interested in vegetation that is above the 45-degree angle. It's quite a visual model, this. It's really quite easy to understand, which I think really helps client engagement. Drive client engagement that little bit further, we sometimes generated 3D models where we could drape the results over the trees to really bring it to life to show you how tall they were. So I might not be able to show you in detail what the model does, but I can bring you some tips that I hope you'll find useful at some point. We had a huge amount of data. And what we found was we needed to break up that data so that FME could process it in chunks. Sometimes we did that by tile, kind of 500 by 500 meter tiles. Sometimes we did that by kilometer sections. So it meant we didn't have to deal with huge data files. We could break it down. We also made really significant use of FME's concurrent processing. So we'd have one parent workspace that would trigger a child workspace tens, hundreds, thousands of times, but we could run that child space more than one at a time. So we could run it up to 7 times in one go. 7 times at the same time on one particular FME engine. And then we'd use multiple server engines and multiple people's computers as well to make sure we were performing as quickly as possible. So the workspace runner is your friend if you want to do the parent-child element. We also stored our data in Azure. This is not something I'd done before, and I was a little bit hesitant, but we had so much data, we needed a central storage system that everybody could get to. So we had people in Network Rail, for example, we had people in Atkins across multiple offices. Of course, this is during the pandemic, so we needed to make sure everyone could get to the information at home too. And we stored our data in Azure, and it worked really well. FME read to and from Azure for our incoming data and for our kind of processing data on the way it would load it back up, our kind of WIP data. The data was chunked up small enough that this also didn't have any particular impact on people's home internet connections. It just worked really well. If internet connections did go down temporarily, which did happen, that was okay, because using this method here that we just looked at, the workspace runner, only 1 or 2 tiles would fail, your internet connection would restore, and then you could continue pulling things down from Azure. And that's something really important about that workspace runner. If you get a section that doesn't work, for whatever reason, maybe your internet went down, or perhaps the tile failed because of bad data in some respect, it doesn't break the whole system. Your model doesn't crash out. You lose 1 or 2 tiles or one processing area, and then you can carry on. And then the next most important thing is only process what you need to. You've seen me show you quite a few 3D diagrams, but actually we processed all of the data in 2D because it's so much quicker. And we really, when we thought about it, we didn't actually need to process in 3D. So the only 3D element here is the height of the trees for the extended action area. So the distance from the outer rail we knew, and the tree height we knew. And if the tree height is more than the distance from the outer rail, then that tree is encroaching, that vegetation is encroaching. And we could do that from the LiDAR data because we know how tall the trees are. So a little bit of thinking meant that we could process things a lot quicker. And then we did something more unusual. So many of you will be familiar with the term agile to describe a software development approach that emphasizes teamwork, frequent delivery, close customer collaboration. There are many agile methods, and we use Scrum. So whilst R&D for geospatial analysis is not strictly software, it turned out to be a really good method of working because it emphasized frequent delivery and close customer collaboration. So at the end of our R&D project, it wasn't a surprise what our client got. The client knew exactly what they were getting because every 2 weeks we had sprint meetings. We decided what we were going to achieve in the following 2 weeks, and the priorities of what we were going to achieve were very much driven by the client. So it's a really client-focused engagement method that works really well for R&D, and this wasn't something we tried before. Now, you might think frequent delivery, close customer collaboration, those elements are quite theoretical unless you really know how to achieve them. And of course, there's a bit of a problem here. I'm talking about quite a complex model with quite complex geospatial challenges and a great deal of data. And our R&D and using Agile was only going to work if we could communicate that we had these complex geospatial challenges in a way that meant something to the client. And this is where R&D and FME really went well together. FME allowed us to generate the visual outputs of all our data sets, where they were in the real world and what their challenges were, in a really meaningful way to the client. That drove their understanding of the model and of their data, which drove their ability to set priorities, which meant that we were delivering to the best of our ability for our client. We can output those visual diagrams, pictures, at every stage of translation in FME, so after every transformer, which means there's nothing that's a black box to the client. We can really show them what it does. And more importantly, when things aren't working, we can really bring it to life why they're not working, what particular bit of data is causing us a problem, for example. We also found that because FME is very easy to use, our startup time was very quick. So if we had a new challenge that we were coming across, we could normally get something going really quick. And then once we got it going, we could scale it quickly. We could provide a little bit of more input to the code, and then normally it was ready to go. We could chunk through huge amounts of data very, very quickly. So there wasn't the lag time between working out how to do it and then scaling it. We were able to generate results for the whole of Wales and for the whole of the East Anglia route in a week each once the model was ready. I think the other important thing to notice is we could show the client data they'd never seen before. So while it was their own data, visualizing your data, especially large amounts of LiDAR data, is very difficult if you're not a GIS professional. So a lot of that feeds straight into why our R&D could go into production straight away. The client was confident in what we'd achieved because they understood it. They'd helped drive the priorities, and the FME code was understandable. You've all seen FME. All the transformers are named. Your annotations can be really descriptive. You can really bring it to life in your annotation. So it meant our production team reading the FME when we finished the R&D and this went straight into production for a wider network rail tool, we're able to just read what happens and build it into the production system. I was able to hand over the R&D straight away, which was really nice to see. So overall, I think what I really want to emphasize is that FME can be used as a communication tool. And I'd never really thought about it like that before. I'd always thought of it as a data crunching analysis tool, but here we really used it for our communication. Its ease of use and flexibility lended it really well to an agile project where we needed to get going very quickly. We needed the code to be scalable, and we needed the code to be able to be understood by the production team. So overall, it went really well. I credit FME with a great deal of that success. And I hope there's something in this presentation that you're able to take away today, whether it be a transformer I let you know about, or perhaps working in a more agile method. Thank you very much.
Thank you, Jenny. That's excellent. I think it's interesting for me. I'm a very visual person, so that's a classic example of a picture paints 1,000 words, that project. Jenny, do you want to come on to camera? There you go. You have done fab. I just couldn't see you. There we go. So actually, Simon, I think you were just going to chip in just on the last session.
Yeah. We had a last-minute question come in from Stella saying, has anyone connected to the new OS APIs? And the answer to that is we've recently done some work with the OS Features API, so we can connect to that nicely and download OS Master Map topo area and topo line and topo point and all the rest of the good stuff in that API. So yes, we have. It's possible, and it's reasonably straightforward to do. But if there's anything more specific, if it wasn't the OS Features API, it was maybe another one that you're interested in connecting to, then please let us know, and we can talk to you about that too.
Fab, thanks. Jenny, the workspace runner seems to be getting some love today. It's cropped up a couple of times. When you said it was used in the project, were you running thousands of jobs? How were you distributing the workload? Were you doing it across multiple machines?
Yeah, we did it across multiple machines. So because this was R&D, we didn't have access to a full production environment. So there was me and a couple of colleagues working on this project, and we had 3 machines between us, each quite powerful machines. And then we did have access to an FME server,
Right.
but we'd borrowed it off another project, so we couldn't just swamp it with jobs.
Yep.
So what we'd do is kind of say, we need these 4,000 tiles to be run on the server, and then we'll split the rest of them between everyone's computers. So we'd set off batches, and then for each of those batches, the FME scripts would find out how many child workspaces they'd need to trigger, and they'd just churn through it.
Mm-hmm.
And we found quite a lot of the time that a child workspace would fail, either because the data wasn't very good and it encountered something we hadn't coded it up, we hadn't coded the FME to deal with, or because the internet connection would drop.
Mm-hmm.
And by running it with the kind of parent-child relationship at the end, we could just do a quick log, check what had worked and what hadn't, and just rerun the few that hadn't worked, or go and have a look at why they hadn't worked. Often running them in kind of like full inspection mode to find out why a couple of the tiles would have failed.
Fab. There was one almost throwaway comment that I think I'd like to dig into a little bit more in your session. You mentioned that you didn't actually process 3D, or didn't process the data in 3D, and yet, you know, the project sort of relies on that z-axis, the third dimension. Have you got any tips of how you went about excluding the z-axis from the equation?
So ultimately, we needed to know that vegetation was encroaching. So we had our different zones, and we needed to know that it was encroaching. And with the exception of that third area with the 45-degree angle bottom, it was either in, because there was vegetation there and therefore encroached, or it didn't encroach.
Yep.
So it was a really black and white thing. And when you really thought about that, yeah, the data was 3D, but we didn't need that axis of height. We just needed to know it was or wasn't present. So we tried to break down the data to just the bits of it we actually needed. Like, what did we need to answer the question? We only needed to know the vegetation was there. We didn't need to know what height it was. And it wasn't until we got out to that 45-degree angle section that we needed to know the height. And then a little bit of quick trig said, actually, you can work this out without having to do it in full 3D and really crunch it. You can just go, we know the height of the tree. We know how far away the tree is from the rail, which allows us to evaluate it in 2D, i.e. just take 2 numbers and evaluate them. You don't need to build the whole 3D model and then get FME to do a really complex intersection.
Yeah.
It did take us a while to get there, though. We thought it was a 3D project when we started.
No, it's really interesting. We see this a lot. Scenarios where people get stuck into a project and start processing the data, and towards the end realize that they've processed things that they never needed to process. And I'd urge everybody embarking on a project to take a step back and look at what the answer is you're going to try and achieve, and then assess the data in that context of what the answer is, because you can find that you can do well, frankly, a hell of a lot of data processing unnecessarily otherwise, which will slow you down. So I was really fascinated to see you pick up on that, because it's...
I should say it took us a good 6 weeks to work that out, from the standard to figuring out how to do it.
We've got a question in that I don't understand, but it might be because it includes some rail terminology. I sort of understand the latter half, but not the former bit. So there's a potential typo in here, but we'll see whether it's just me. How did you filter out the catenary and poles? Catenary, I'm not familiar with what. Oh, catenary. Catenary? Does that mean anything to you?
Good question. I'm not sure I understand it either.
I'm not sure what a catenary is.
Cables
Cables and power
lines.
lines. Oh,
I'm with you.
gantries. Right, fine.
Gantries, right. It's because the LiDAR was pre-classified. So when the LiDAR reached us for the project, we already had a classification in it just for vegetation. So we didn't actually need to deal with the cables, the power lines, any of the other things that the LiDAR would show up. It was really easy. We just took the vegetation class and dealt with it that way.
So you just read in the classification that you needed rather than reading everything in and filtering it out.
Yeah, exactly. Fine. And there are times when we needed to know whether there was overhead line electrics, and that kind of thing. And that all came in as vector data from network.
You got a lucky you comment.
Yeah, we were lucky.
So is that down to the way that the LiDAR was captured, or was it sort of post classified by a third party?
So the LiDAR data for Network Rail is done, I think it's roughly every 2 years, and it's a full-on scheme for them. It's a huge project. And it's captured in a way that means they know it will be classified before it gets kind of given to people like me or anyone else in Network Rail to use. They've got like a set schema for it. So it's the same every time they capture it across the whole country. Okay.
And how did you go about proving that the answers that FME was giving you were accurate? Did you do any ground truthing or manual analysis? What did you?
We spent quite a lot of time thinking about this, and quite a bit of the work was black or white. So it either was encroaching or it wasn't. It wasn't a typical model in that you have a percentage range that said we're 90% sure this is the case. So you could say if the LiDAR data is correct, and you've already validated the LiDAR data from the huge LiDAR projects that go on, and if our zones are correct, which means you captured your lines in the right place, your vector data is correct, we're pretty certain our data is correct. We did go down a route of whether we should manually do proper ground truthing. Biggest problem with that is vegetation changes quite quickly, and your LiDAR is captured every 2 years. So yeah, typical model that you might study at university or that might be machine learning, something like that, would have a percentage classification of how accurate you thought it was. It's not really relevant here.
Okay, thank you. I think the statement in there about FME as a communication tool is the one that really struck home for me. It's something we try and advocate as much as possible as well, really, because it is absolutely a comms tool. It allows you to see data flowing. It allows you to see a real live flow diagram through which data is passing through decision gates, so you can see which way it goes through the flow. Your documentation allows people who are trying to feed through what's actually happening. So yeah, it's really interesting to hear that said as well. So thanks so much, Jenny. Really appreciate your time.
You're welcome.
Thanks a lot. Cheers. Okay, so last slot of the day goes to Sam Anstis, and I'm just going to switch over to that pre-recording. So over to Sam.
Hello everyone, and welcome to my talk, Data Wrangling for Efficient Decision Making in a Large Infrastructure Project. My name is Sam, and I'm a GIS consultant at Mott MacDonald. Today I'll be showing you some of the ways we've used data wrangling to structure, validate and enrich raw data containing thousands of borehole records to produce analysis-ready information. So the project I'll be talking about today has been part of a collaborative effort between our GIS and agriculture and soils teams. We were and still are tasked with producing around 161 soil resource plans for land holdings, each requiring about 5 to 6 drawings, and this amounts to about 966 drawings in all. We were provided with soil borehole data, which we used to infer certain key soil management characteristics. Most importantly, this includes things like the soil horizon thicknesses, soil volumes for both the stripping and the capacity of soil stockpiles, the soil nutrient levels, and the soil handling units. 3 types of plans were required for each report, showing the agricultural land classifications, the soil handling units, as well as the stockpile and stripping locations for each site in question. We saw ways of improving the efficiency of the drawing production. Where processes were previously done manually, we saw an opportunity for a bit of automation. To do this, we created a workflow using tools developed in both FME and ArcGIS. The primary borehole dataset these plans are based on amasses around 18,000 points, with periodic updates increasing its size over time. The original data was not usable for our purpose, partially due to inconsistencies inherent in the data, and partially because we required more information than is present in its raw form. However, we can glean what information we needed from information that is present. The primary elements of the dataset that we needed to modify and enhance or extract were the soil horizon thicknesses, the average mineral content for each holding, soil texture, and resilience. There were also a large quantity of duplicate horizons present for many of the boreholes, numbering in their thousands, so an automated method of dealing with these was required if we were to produce results in any reasonable amount of time. To this end, we created an automated process that can repeatedly produce a consistent and more comprehensive dataset that is ready for analysis. Firstly, with the aim of creating a consistent dataset, we had to implement preliminary validation. As data enters the workbench, a custom transformer, made up of testers and string replacers, assesses the holding ID against a simple regex expression. This ensures that the ID follows a consistent format. Next, we split the workflow to assess the mineral content and soil horizon thickness separately. For the mineral content, this is a simple task of using the attribute accumulation settings within the aggregator transformer to summarize the mineral content of all boreholes within a given landholding. This stripped the data of its geometry, but we can use the landholding ID to pair this back up with the data later on in the workbench. So next in the workflow, we assess the borehole depths, which will let us calculate thickness. This is, I think, where the power of FME really came into its own. As in this example, the depths from the dataset were not recorded consistently. All show depth below the surface, however some included minus values, some didn't, and some had a range, showing depth at the top and the bottom of the horizon in question. Each horizon is recorded as a row in the table, and therefore is a separate point within GIS. Where we had a range, we could easily extract the thickness with ease. However, dealing with single figures for depth was more difficult. To accomplish this, we split the flow by soil horizon. These include the topsoil, the upper subsoil, and the lower subsoil. We then apply some formatting before merging each layer with the one that sits above, using the X and Y coordinates to merge the two. For the top layer, as this sits on the surface, we could apply a surface value of 0. By merging the layers, we get the lower and upper depths for each, which are then used to calculate thickness. We couldn't leave the data at this point, however, as due to the variability of the soil texture, when the texture shifts enough to justify the attribution of a new texture, they duplicate the soil horizon in question and attribute a new texture. For the purpose of mapping the three horizons, we needed to amalgamate these duplicate horizons into one. We achieved this for each horizon, firstly by sorting the data by depth and by borehole survey ID. We then matched the data using the X and Y coordinates of the points, attributing them with a match ID, which essentially grouped each set of borehole points by borehole location. We then created lists which contained the depths of all duplicate points. Those that did not have any duplicate points were filtered out. As we didn't need to deal with these, we could take them out of the workflow. For the duplicates, we then marked them as such and used the adjacent feature comparison settings within the Attribute Manager transformer to compare the features of each point with that of the row above it. Because we'd already done sorting for location and by depth, the boreholes that sat above the point in question should, if it was within the same borehole, be stratigraphically situated above the row being tested. And so the lower depth of the borehole above should be the upper depth of the one below, and we could attribute that as such. This process allowed us to get the upper depths and lower depths of all soil horizons irrespective of any duplicates and calculate the thickness. Once we had these values, we stored the geometry of the points and then aggregated all points by match ID. This created a list of start and end depths and summed the thickness. We then converted the data back into points using the stored geometry and tidied the data up a bit. The aggregator provides the sum thickness of the duplicates, but we still needed to record the maximum and minimum depths, so we used a little bit of Python here to extract those from the list generated by the aggregator. After this process, we could bring the data back together to create a dataset with consistent depth and thickness values, as well as the newly calculated average mineral content for each of the land holdings. The final bit of the process we did there was to take the codes that denote the texture of the soil and convert them to more general resilience values and soil handling unit values. This was performed using another Python caller. Finally, we could output the data from the workbench into a geodatabase for further processing within ArcGIS, as well as formatted a multi-sheet Excel workbook that contains all the required logs generated throughout this process, which aids in the QC process. So, the results. Firstly, by using this data-led approach, we are able to deliver analysis-ready data in a timelier manner. Automation of this process ensures a consistent method is applied in the production of key soil metrics. And finally, this workbench, alongside other GIS automations we have developed, have reduced the time to produce a set of drawings by half, helping to deliver products of better value to our clients. So to conclude, FME has helped us to wrangle our data into a standardized schema, ensuring the naming conventions are upheld and a consistent format within the data is maintained. The automation we have developed here has allowed us to infer new information from the existing data, a process we will be able to consistently apply as new data is received. And finally, the outputs of this workbench can be easily ingested by GIS and processed within our complete GIS solution for the production of our soil management plans. In all, this process allows for faster and more consistent outputs alongside detailed logs for easy quality control and more informed decision making. And that's it. Thank you very much for your time and for attending my presentation. I would just like to say a special thanks to Hannah, Gwilym and Mike, who have had input and feedback on this process throughout. It's been much appreciated. I will now take any questions anyone has. Thank you.
Let's just flick over to the holding slide. Couple from me to begin with. You had a cool flow diagram in your presentation that you'd used to sort of describe the process. Is that a specific tool that you used?
I need to double check.
Can you remember?
I don't think it was. It might have been Visio, but I'm not sure. I'll have to double check.
Yeah, no, it was interesting. I think we often sort of advocate using FME as its own flow diagram, but sometimes, you know, that decent flow diagramming tools are sometimes hard to come by. So that would be interesting if you can dig that out at some point.
Yeah, this. I mean, the workspace kind of grew and grew, so it was a bit simpler to just sort of, especially because we were using other tools such as ArcGIS. It was easier to kind of show a simplified process. It was Lucidchart that we used.
Oh, there we go. Someone's popped that into the chat as well. Super. Okay, so I had a DM come in, and I thought I'd hand it over to you because it's an interesting one. In some of your screen grabs, you had some blue dots that looked like floating dead ends in the workspace. What are they, and what do they do?
The tunnels, do you mean?
Yeah, I think you had tunnels on the end. Yeah.
Yeah, it was. Well, primarily it was just to help sort of segregate the workspace into neat sections, and it helped for screenshots, so it didn't have lines going everywhere.
Yeah.
But the tunnels just went to different parts of the workspace because I only showed sort of screenshots of different bits that were of interest to the power sort of presentation.
Cool.
But yeah, there were just tunnels to other parts of the workspace.
So and the blue dots, for those of you wondering, they're called junctions. It's actually a transformer. If you go and search in the transformers list for the transformer junction, you'll find it, and you can drop it onto the canvas. It's effectively a sort of an imploded transformer. It literally just allows you to collect connections together. So there was some Python in your process. One person here was asking me, did you really need to use it, or was it in the example you gave, was it just simpler to code up those scenarios?
I imagine we could have found a solution within FME, but I already had some scripts that I'd used to do similar things. So it was easier at the time to just take those scripts and modify them so they would fit within FME.
Yeah. Are you you are around Python yourself?
Pardon?
Do you know your way around Python yourself?
Yes.
Yeah.
Okay. Yeah. Sort of been trying to develop my automation skills in FME and Python at the same time.
I saw quite a cool tweet from somebody a little while ago. They basically said, if you know how to write Python, you know a little bit of regex, and you know how to use FME, you don't need anything else. You know, I mean, it's arguable, but it's certainly an interesting statement. On regular expressions, we've got Mary's doing a dedicated session around regex next week, sort of a 30-minute 101 for regex if anybody's interested. Python is obviously a language that integrates very, very neatly with FME, but also with Esri, which a lot of GI people use. So that works quite well. Super. Thank you very much, Sam. Really appreciate your time today. Cheers. Thanks a lot. Okay, well, there we go. A few great sessions that hopefully stimulated a little bit of thought about how you can use FME, perhaps in a new way you haven't previously thought of. And also buried in each session were a few specific tips and tricks that will help you to improve your plate spinning skills. From now, then, all it leaves me to say is a few quick thank yous. None so important really as to our speakers there, Gwilym, Jenny and Sam. Without the actual users of FME kindly volunteering to present at our event, it's harder to get the context and therefore harder to understand the value that FME adds. New features are certainly cool, but they're not what justifies the business case for FME. So thank you very much to all three of you. We do really appreciate it. I should also note that Jenny not long ago also achieved the dizzying heights of her certified FME professional accreditation. Jenny is now listed on SAFE's Hall of Fame, and the accreditation is one that you as an individual can carry with you as a personal achievement as well. So presenting at these events like this it's a way of raising your profile. It also makes it easier to achieve your own certification because you can use it as part of your submission. So well done to Jenny, and if anyone is interested in taking part in something like this in the future, please do drop me a line. I also wanted to let you have a few resources after today. Firstly, all of our scheduled FME trainings listed on 1spatial.com/training. And any recordings and events and webinars along with the recording of today's event always end up on our on-demand page. SAFE's community pages mustn't be missed as well. Over there you'll find thousands of how-to articles, and importantly that's where the chat forum is, effectively the Stack Exchange for FME. And lastly, if you've got a generic inquiry, just send it to fme@1spatial.com and we'll help you out. Also, if you know you're an existing customer on active FME support and maintenance, you get access to a special dedicated service, and this is the quickest way into that. So just send us an email at support@1spatial.com. But if you're not sure about your status, just nudge Charlie on the chat now, and she'll be able to give you an update. So you can ask her the question. For those of you that don't know already, we've got a full range of online public training courses that you can attend on a per delegate seat rate. We also do private courses, and we use a variety of online platforms on the depending on the specific requirements. So as a special thank you for joining us live today, if you inquire about a training place this month on one of our courses, you can use the code 1SFMEWF10. So that's 1Spatial FME World Fair 10% effectively to get yourself a 10% discount. There's a few T's and C's, but we can discuss those when you contact us. To find out more, you can either reach out direct to Charlie Doherty on the Zoom chat, or her email is listed, so you can drop her a note with your details. The next scheduled desktop and server courses are in May and early June, but we've got courses scheduled through to December against which that discount code is valid. And don't forget, this is part one of our two-part event. Today we've focused on customer usage around FME, but next week on May the 12th at 10:30, so slightly different time, a little bit later, 10:30, we have a second session that includes effectively 3 mini training sessions. I'm going to cover some of the latest features in FME 2021. Simon's going to do a Webhooks 101 session that can't be missed, and Mary's going to take you through regular expressions and why you really need them in your life. So go to the World Fair agenda and go and add us, in addition to all the other sessions you've been attending, to your schedule for next week. And finally, this is just a save the date point, really. So many of you will have attended our annual conference before, either in person or online, but do please go and register your interest in our Smarter Data, Smarter World 2-day conference on November 10th and 11th. And you can do that at 1spatial.com/events. And that, as they say, is it. So thank you very much. The team are going to hang on online for a few more minutes to deal with any further outstanding questions, but other than that, we hope to see you again next Wednesday for our companion event. So thank you very much, and hopefully see you again soon. Cheers.